Hey everyone, and welcome to a deep dive on something that I think we all kind of struggle with at
Yeah.
some point in our FPGA journeys, and that is timing closure.
It's a big one.
It is a big one, and we have some great resources today that go way beyond the basics.
Yeah, we're going to get into some really advanced techniques and tools,
Yeah,
even open source stuff.
yeah. And I'm excited to talk about some of the open source stuff because that's something I've been meaning to dive into myself.
It's amazing what's out there now.
Yeah.
It used to be all commercial tools.
Yeah,
But the open source community is really stepping up in this area.
that's awesome.
It's a really rapidly evolving field with,
Right.
tons of innovation, especially as these FPGAs get more and more complex.
Right. Yeah, so I think just to kind of level set for everyone, timing closure, it's all about making sure that every signal in your FPGA design arrives exactly when it's supposed to.
Right.
It's like if you think about it like a really carefully choreographed dance, every signal needs to hit its mark precisely at the right time for everything to work.
Yeah, that's a great analogy.
Right. And if things are off, well, you can have some pretty bad outcomes.
Yeah, you can end up with functional errors like,
Yeah.
your design just doesn't work the way you intended it to,
Oh, yeah.
or unpredictable behavior.
Right.
And as these FPGAs get more and more sophisticated,
Yeah.
with more logic packed into a smaller space,
Yeah.
it just gets harder and harder to meet those timing requirements.
Okay, so yeah, things are only getting more challenging, so we need to up our game.
Absolutely.
So let's talk about strategies. Like what are the things that we can start thinking about? And actually, AMD Xilinx has this, I don't know if you want to call it a philosophy, but they have this ultra-fast design methodology.
Yeah, it's a set of best practices, basically.
Yeah.
And it all starts with what they call early planning.
Early planning. Okay, so you're not just...
You got to think about timing right from the get-go.
Right.
Even before you start,
Before you write any codes.
writing your HDL code. You have to be thinking about how your design choices are going to impact timing down the line.
Okay, so what would be some practical tips for someone in that early planning stage? Like what kinds of things should they be thinking about?
Well, one of the most important things is to choose the right clocking scheme for your design.
Okay.
Think about the frequencies you need, the relationships between different clock domains,
Yeah.
and how you're going to manage those tricky clock domain crossings.
Right. Yeah. That's always fun.
Another crucial thing is to select the right HDL coding style.
Oh. Okay.
Believe it or not, certain coding practices can actually lead to timing issues.
Right.
So you need to be mindful of how your code is going to translate into the physical layout of the FPGA.
Okay. So it's not just about, getting the functionality right. It's about understanding the implications.
You got to think about the physical implementation
Right.
from the start.
Okay. So you got to think a few steps ahead.
Ooh, you could say.
Okay. And then once you have a solid plan in place, that's where these powerful tools that we were talking about come in.
Right.
Like Vivado, which is AMD Xilinx's flagship design suite.
Yep, that's the one.
Yeah. So let's talk about Vivado.
Yep.
It's known for having some pretty impressive physical optimization capabilities.
Oh, yeah. It's got some really sophisticated algorithms for placement and routing.
Okay.
It's all about minimizing those delays.
Mhm. Right.
It can even do things like over-constraining clocks during setup timing, but then resetting them before routing
Okay.
to avoid what we call hold violations.
Hold violations, I think maybe people aren't familiar with that.
Okay, so basically you have setup timing,
Okay.
which ensures that a signal arrives early enough to be properly registered by a flip-flop on the next clock edge.
Gotcha.
But then you have hold violations, which happen when a signal arrives too early,
Okay.
before the flip-flop has finished processing the previous data.
So it's like showing up, 10 minutes early to a meeting when
yeah.
they're still in the previous meeting.
Exactly. It's like trying to cram more people into an elevator that's already full.
I got it.
It just won't work.
Okay, so Vivado's doing all this stuff behind the scenes to prevent those mishaps.
That's right. It's doing a lot of heavy lifting for us.
Wow, that's pretty impressive.
Yeah. And it's not stopping there. They're also using machine learning now
Oh, wow.
with what they call intelligent design runs, or IDRs,
Okay.
to try and automate timing closure for those really complex designs.
That sounds super powerful.
It's like having a superpowered assistant that can explore countless possibilities to find the best solution.
Yeah, that's awesome.
And then you also have some dedicated timing closure assistance tools within Vivado
Okay.
that can help you pinpoint violations, suggest fixes, even automate some of those fixes for you.
Okay, yeah, so it's getting pretty smart.
Oh, yeah. It's definitely getting smarter.
Okay, and speaking of smart things, you know what else can be a real game changer?
Uh-huh.
Scripting.
Oh, yeah. Scripting is huge.
So it's like taking control of the timing closure process and writing your own rules.
Absolutely. You can automate analysis,
Okay.
extract data, identify those critical paths that are causing you headaches, and even suggest fixes.
Right. Yeah, because sometimes those tools will just be like, oh, there's a violation. And you're like,
Yeah, they don't always give you the best guidance.
right. Yeah. So it's
Yeah.
like, okay, I need to dive a little deeper here.
Exactly. And scripting lets you do that.
Okay, cool.
Yep.
So what are we talking about in terms of scripting languages for Vivado?
Well, the main ones are TCL and Python.
Okay.
TTL is Vivado's native scripting language.
Right.
So it's incredibly powerful,
Mm.
tightly integrated,
Yeah.
and gives you really granular control over all of Vivado's features.
Okay.
Python, on the other hand, is a more general purpose language.
Okay.
It's super versatile, can interact with Vivado,
Uh-huh.
and you can even create standalone tools with it.
Oh, cool.
And it's becoming super popular in the FPGA world because it's easy to read and it's got this huge ecosystem of libraries.
Yeah, I've definitely been seeing a lot more Python stuff popping up.
Oh, yeah, it's definitely gaining traction.
So both have their strengths, it sounds like.
Yeah, TCL for deep integration with Vivado and Python for flexibility.
Right. Okay.
And now here's something that might surprise you. There's a growing movement towards open source scripts and tools for timing closure.
Oh, really?
Yeah, it's
Well-
really cool. It's making these advanced techniques
Okay.
accessible to everyone.
That's amazing.
So you don't need those expensive commercial licenses anymore.
Okay, so what are some examples of those open source tools that we can look at?
Well, there's one called OpenTimer.
Okay.
It's known for being really fast because it uses parallel processing
Wow.
to analyze timing.
So this is like instead of hours, we're talking minutes.
Yeah, exactly. You can shave off tons of time,
Wow, that's a huge difference.
especially when you're working with those massive, complex designs.
Okay, so what else is out there?
Another good one is OpenSTA,
Okay.
which provides a really comprehensive and accurate static timing analysis environment.
Okay, yeah, I've heard of that one.
It's a great tool for really understanding the timing behavior of your design.
Yeah. And we also have Kimai on our notes here, which is a time tracking tool.
Yeah, that was a little different.
Yeah, so I'm curious how that ties into timing closure.
Yeah. Well, we often spend countless hours,
Yeah.
sometimes late into the night,
Huh.
wrestling with these timing closure challenges.
Yes, we do.
And Kimai can help us track that time.
Oh, okay.
Analyze where we're spending the most effort
Yeah, gotcha.
and ultimately become more efficient in our workflow.
Okay, yeah. So it's about acknowledging that human element,
It's
right?
terrific.
That we're all kind of spending our time and our sanity sometimes trying to,
Yeah, it can be a real time sink.
yeah, it definitely can. Okay, so we have all these powerful tools and scripts now, both commercial and open source.
Right.
But how do we actually put them to use?
Well, imagine being able to instantly identify like the top 10 worst performing paths in your design,
Okay.
or analyze clock skew
Mm-hmm.
to spot potential issues before they even become problems.
Mm.
Scripts can automate these tasks and provide valuable insights that would take you hours to uncover manually.
Yeah, that's awesome. And you could even automate the process of generating constraints,
Oh, yeah.
which is kind of a tedious task.
Nobody likes doing that.
Right.
It's like having a personal assistant for timing closure.
Exactly.
Yeah.
Yeah. And then there are more advanced techniques like pipelining,
Yeah, pipelining is a big one.
which, I mean, people who are listening to this probably already know about, but maybe we can talk about the different types of pipelining that you could use.
Sure, you can explore multi-cycle architectures
Okay.
where operations are spread out over multiple clock cycles,
Right.
or implement fully pipelined architectures for higher throughput.
So pipelining, just as a quick refresher, it's basically where you break down a complex operation into smaller stages.
Right. Yeah.
And each stage is handled by a dedicated section of the circuit.
Exactly. It's like an assembly line
Right.
where each stage contributes to the final product.
Yeah. And so by doing that, you're effectively reducing the critical path length, which allows you to run at higher clock speeds
Exactly.
without violating timing constraints.
And you can boost performance without sacrificing functionality.
Perfect. That's what we like.
Yeah, exactly.
Okay. So this is all incredibly fascinating.
It is a deep rabbit hole.
It is. I'm starting to see how deep it goes, and it's a little overwhelming. But sometimes even with all the best tools and techniques, you need a little help,
You got that right.
from other engineers.
Yeah, absolutely.
So what do we got for that?
Well, the AMD E-Links forums are a goldmine for timing closure discussions, scripting tips,
Okay.
even workarounds for those tricky edge cases.
Right. Yeah. Those forums can be really helpful.
Yeah, it's a great place to connect with experts and learn from their experience.
And then there's the Reddit community, right? RFPGA.
That's always buzzing with activity.
Yeah. There's a lot of good stuff on there.
And you can find people who are grappling with the exact same timing closure challenges you are,
Right.
sharing their solutions, offering support.
Yeah, and it's great because you're getting all these different perspectives.
Yes, the collective wisdom of the crowd.
And then if you want to get a little more formal,
Oh.
there's the Z-Links University Program, XUP.
Yeah, they've got workshops, tutorials, courses that go deep into timing closure
Yeah.
and other advanced FPGA design concepts.
Yeah, so it's a good way to get a more structured learning experience.
Definitely.
Okay, so wow, there is a ton of knowledge and support out there.
There really is.
It's pretty amazing.
Just got to know where to look.
Yeah, I think that's the key takeaway here is that timing closure, it's a challenge for sure.
Yeah.
But it's a solvable challenge.
Absolutely.
And there are tons of resources out there to help you.
You don't have to go it alone.
Yeah, you don't have to bang your head against the wall by yourself.
That's right.
So, and I think that's a really important point is that, even if you are feeling overwhelmed, there are people out there who have been through it and there are solutions.
And what's really exciting is that it's not just about fixing individual problems.
Okay.
It's about approaching your design holistically.
Right.
Thinking about timing from the very beginning.
Okay.
And using all these tools at your disposal to create a design that truly sings.
Yes. Beautifully said. So before we move on to part 2, I just want to leave you with a thought.
Okay.
We've talked about these increasingly complex FPGAs, and the tools and techniques are constantly evolving to keep up.
It's a moving target.
It is. So where is all of this headed? Like, what does the future hold for timing closure?
That's a great question.
As these FPGAs continue to evolve at such a rapid pace.
That's something we'll definitely be tackling in the next part of our deep dive.
Yeah, so stay tuned for that.
So buckle up, because things are going to get even more interesting as we explore the potential breakthroughs and challenges that lie ahead.
Awesome, I can't wait.
Welcome back to our deep dive into timing closure.
So we've been talking about all the challenges and all the different solutions out there.
Yeah, a lot of technical stuff.
Yeah, and the different approaches that AMD Z-Links have. But I think there's also like a human element to all of this, right?
Oh, absolutely. It's not just about the tools and techniques.
Right.
It's about how we as designers think about timing closure.
Yeah, so it's like our mindset.
Exactly. You need the right mental framework to really tackle this stuff effectively.
Okay, so how do we develop that timing closure mindset? What would you say are some of the key things?
Well, I think first and foremost, you got to embrace timing closure as an integral part of the design process itself.
So it's not something you just tack on at the end.
No.
Like, oh, I'll just fix the timing violations later.
Nope. You got to be thinking about it from the very beginning.
Okay, so it's like baking a cake.
Okay.
You can't just add the baking powder at the end, right?
Right. You got to mix it in from the start.
It's got to be part of the whole process.
Exactly. Otherwise, your cake's going to be flat.
Yeah, or your FPGA design is going to have all sorts of timing problems.
Exactly. And that means thinking about timing from the moment you start writing your HDL code.
So it's like every line of code you write, you're thinking about how is this going to impact timing?
Yeah, you got to choose the right coding style.
Mm-hmm.
Understand how your choices impact timing.
Okay.
Even consider things like clock domain crossings.
Yeah. That always gets a little tricky.
It does, but if you lay the foundation right, it makes timing closure so much easier.
So it's like almost playing a game of chess.
Okay, I like that.
You have to think several moves ahead.
Right. You got to anticipate your opponent's moves, and in this case, your opponent is timing.
Right, exactly. So what would be some of those strategic moves that we can make to kind of improve our chances?
Well, carefully planning your clocking scheme for starters.
Okay.
Using appropriate synchronization techniques.
Okay.
And minimizing logic depth.
Yeah, making sure that those signals don't have to travel too far.
Exactly.
Yeah.
All of those things contribute to a more timing-friendly design.
Okay, so it's not just about fixing the violations. It's about designing it in a way that
It's a proactive approach, not a reactive one.
prevents those violations in the first place.
Exactly. And it will save you so much time and headache later on.
Yeah, that's always a good thing.
And speaking of avoiding headaches, don't forget about documentation and communication.
Oh, yeah, documentation and communication.
Two of the most important things.
They're always important.
Absolutely.
No matter what you're doing.
Especially with complex designs like FPGAs.
Right, yeah, because things can get pretty hairy pretty quickly.
Oh, yeah.
So why is documentation so important when it comes to timing closure?
You need to clearly document your timing constraints. Any assumptions you've made, any decisions you've made along the way.
Okay.
It's not just for you, it's for anyone else who might need to work on the design.
So if somebody else needs to come in and help you debug a timing problem.
Exactly. They can see what you were thinking.
Okay.
They can understand the rationale behind your choices.
It's like leaving a trail of breadcrumbs so you
Exactly.
don't get lost in the woods.
That's a great way to put it.
Okay, and then communication. How does
Yeah.
that play into it?
Well, regularly discussing timing considerations with your team,
Okay.
bouncing ideas off each other,
Yeah.
seeking guidance from more experienced engineers.
Right.
Sometimes just talking through a problem can lead to those aha moments.
Yeah, that happens all the time.
Where you suddenly see a solution that you wouldn't have thought of on your own.
Right. Yeah, so it's not just you in a silo trying to figure everything out.
Nope, definitely not.
Okay, so to recap what we've talked about for developing this timing closure mindset,
Yeah,
it's about integrating timing considerations into every stage of the design process,
from the very beginning.
right from the start.
Absolutely.
Making strategic design choices that are timing friendly.
Thinking ahead, anticipating those potential problems.
And then documenting everything clearly and communicating with your team.
leaving a clear path for yourself and others to follow.
Exactly. Yeah. So if we embrace these principles, we'll be well on our way to mastering timing closure.
And creating FPGA designs that are both functional and high-performing.
So before we move on to the last part of our deep dive,
Mm-hmm.
I want to touch on something that's been on my mind throughout this whole discussion.
Okay.
We've talked about all these complex FPGAs and these advanced techniques and the need for human expertise,
Right.
but it makes you wonder, where is all of this heading?
It does.
What does the future hold for timing closure as these FPGAs continue to evolve?
Yeah. Are our current tools and techniques going to be enough?
Or are we going to hit a wall where our designs just become too complex to manage?
That's a really good question, and I think it's one that we need to start thinking about seriously.
Yeah, because the future of FPGAs is looking anything but simple.
You got that right.
All right, so let's shift gears a bit. And in the next part of our deep dive, we'll delve into that future of timing closure
Okay. Sounds
and
good.
explore what might be coming down the pipeline.
I'm ready for it.
All right, so we're back and ready to wrap up our deep dive into timing closure.
Yeah, we've covered a lot of ground.
We really have, and now we're going to try to predict the future, which is always a little tricky.
It is, but someone's got to do it.
That's right. So FPGAs, they're just getting more and more complex.
They are?
And that has huge implications for timing closure, right?
Absolutely. I mean, denser fabrics, higher clock speeds,
Yeah.
more sophisticated architectures.
It's like trying to fit an entire city onto a postage stamp.
Yeah, and make sure everything runs smoothly
Yeah.
without any traffic jams.
And it's not just about the size and speed, it's also about all the specialized processing blocks that are being integrated now.
Right, high-speed transceivers,
Yeah.
AI accelerators, embedded processors.
Yeah, and those things all have their own unique timing requirements.
Yeah, they do, and they interact with the rest of the FPGA fabric in really complex ways.
Yeah, so it's like this whole ecosystem of timing challenges.
You could say that.
Okay, so the big question is, are our current tools and techniques going to be enough
Yeah, are we going to hit a wall?
to handle all of this complexity?
It's a valid concern.
Okay, so what do you think? Are we going to be okay, or are we going to need something totally different?
Well, tools like Vivado, they're constantly evolving.
Yeah,
They're incorporating more automation, more machine learning,
right.
but I think there's a limit to how much they can compensate for these increasingly complex designs.
So we might need to rethink our approach entirely.
We might, and that's where some of the really exciting possibilities come in.
Okay, so what's on the horizon? What are you seeing?
Well, artificial intelligence and machine learning are huge right now,
Yeah.
but I think we're going to see them being used not just for optimization, but for actual design exploration.
So AI is going to be suggesting design choices that are inherently timing friendly.
Exactly.
Yeah.
It's going to analyze your design intent, understand your constraints,
Okay.
and then propose different architectures or even modify your HDL code to optimize for timing.
So it's like having a timing closure expert built right into the tools.
Yeah, that's the idea.
That's amazing. And I guess it's not about replacing designers.
No, not at all.
It's more about augmenting their capabilities.
Exactly. It's a collaboration between human expertise and AI insights.
Right, because at the end of the day, we still need that human touch.
Absolutely. We need that creativity and that problem-solving ability.
So with AI, we might even see this more holistic view of timing closure.
Yeah, where it's not just about weighting constraints.
Right.
It's about optimizing for power consumption area and other design goals.
So it's like timing closure becomes part of this bigger picture.
Yeah, it's one piece of the puzzle.
Right, and there might be other breakthroughs that we haven't even thought of yet.
Absolutely. We're just scratching the surface of what's possible.
Okay, so the future of timing closure, It's uncertain,
Yeah.
but it's definitely exciting.
It is, and it's going to be an interesting ride.
Well, on that note, I think we've reached the end of our deep dive into timing closure.
Yeah, I think we've covered just about everything.
From the fundamentals to the advanced techniques and even the future.
We've looked at it from all angles.
Yeah, and I think the key takeaway here is that timing closure is a challenge, but it's a solvable challenge.
Absolutely. And there are tons of resources out there to help you.
So don't be afraid to dive in, explore those resources, and never stop learning.
That's right, because the future of FPGA design is being shaped right now.
And you can be a part of it. So thanks for joining us on this deep dive, and we'll see you next time.